Apple II forever, making life better and better. Apple II forever and ever, bringing the rainbow to you.
Well, Xerox PARC was a research lab set up by Xerox when they were making a lot of profits in the copier days. And they were doing some computer science research, which was basically an extension of some stuff started by a guy named Doug Engelbart when he was at SRI. Doug had invented the mouse and invented the bitmap display, and some Xerox folks that Xerox, I believe, hired away from Doug or split off from Doug somehow and got to Xerox, were continuing along in this vein. And I first went over there in 1979, and I saw what they were doing with the larger screens, proportionally spaced text, and the mouse. And it was just instantly obvious to anyone that this was the way things should be. And so I remember coming back to Apple thinking, our future has just changed. This is where we have to go.
There are many ways to move around and to make views, and this is one of the basic features of this tool we have. Well, suppose I worked for some time at this and then call up my wife to get the rest of the list. I'd eventually end up with a whole structure where I could say, gee, there were a lot of things. A market, shoe store I have to stop to. Let me see what I was supposed to get in the market. Oh, produce, cans, cereals. What about cereals? Oh, cereals, bread, noodles, like that. Okay. Back up there, if I want to look at the numbers, that's what I can. If I want to open up everything, see that, or many lines. There are many ways in which I can. But there's another thing I can do. There's a route I said I have here. So here, I'm afraid I'll need a different picture of the view. So here's what I drew with a picture drawing capability here. It's a slight map if I start from work, and here's the route I seem to have to go to pick up all the materials. And that's my plan for getting home tonight. But if I want to, I can say, the library, what am I supposed to pick up there? I can just point to that, and oh, I see, overdue books and all. Well, there was a statement there with that name on it. Go back. What am I supposed to pick up at the drugstore? I see, very interesting. All right. I can do things if I want to just say, I'd like to interchange produce and canned materials. Bingo. And they're all numbered rightly if I care to look. Interchanging them very quickly. Cans are going to get interchanged with produce. They do it and all gets renumbered. So I have ways of studying over, making different views, moving around, going to specified points, and modifying the structure. At the same time, I've seen that I have a repertoire of different entities, like character, knock off that character, replace a character, make that P. So I have entities of all sorts that I can say I want to do operations on, and this basic structure that I can move over and study and get about very quickly. This is the staffing over the years from 1950 on, and it's had slightly bumpy history. During these years, there was only one of us. Basic goal, improve the effectiveness with which individuals and organizations work at intellectual tasks. What does their effectiveness involve then? Better solutions, faster solutions, solutions to more complex problems, with better use of human capabilities. Really thinking about that. But a corollary goal is, besides improving the effectiveness, to develop a system-oriented discipline for designing the means by which greater effectiveness is achieved. Can you hear me, Don? Would you turn it over and we'll see, right? Its principle is that there are two wheels that roll on the surface, but since they're at right angles and kind of sharp edges, one roll and the other slide in one direction. Each of these wheels controls through a potentiometer with a voltage output sampled by an 80V converter. Other features of the mouse are that it stays put. I can lift it and replace it without having a spot change, so I can adjust where I want it for my comfort. And these control buttons on the top are used quite a bit, and I'll show you a little bit later how some of those are used. Now, the keyboard in the middle is essentially a standard typewriter keyboard, except for a few special keys out on the side. The computer knows it instantly when you hit one and makes an appropriate response. This device over here is unique to us, and we always have to justify and explain it. We'll do it in reverse order. We'll explain it first. It provides for you the one-hand equivalent of what you can do with a keyboard. There are 5 keys, and normally each finger sits on a key, and depressing any one key at a time produces a character. And any 2 keys at a time also. And in fact, any combination of depressing, of which there are 31 combinations.
In my left hand, I'm using a 5-finger keyset in which I can, using chords, type characters that I could otherwise type at the keyboard. And in my right hand, I am using a mouse pointing device, and the combination of inputting commands at the keyset and pointing with the mouse is actually a little faster than switching between the keyboard and the mouse. So the keyset will be helping me through this. This demonstration is about the Augment Reference Handbook, which is a dynamic hyperdocument. We'll talk more about hyperdocuments as we go along. And we're using a computer system in St. Louis, Missouri, connected to that system by a TimeNet connection. In the screen here, at the top of the screen, is some system feedback information, a command line, the base editing system, and some special view indicators to show what kind of a view we have at the moment. Now, I want to activate a command that will split our screen into several windows. And these are some topics that I'd like to cover as many as we can in the time that we have here. The information environment that the Augment system supports. I'm going to talk about where it is, what it is, and get some ideas about how to access it. The Augment system supports some computerized libraries called journal libraries. And there are many different libraries depending on which organization is supporting them. There's an Augment library, an Augmentation Systems Division library, and others. And there's information in those various libraries that people want to tie together. And then there's also operational information, user guides, program documentation, things of that nature. And of course there's a lot of personal information in an Augment system. You can see this last view is going into the bottom window. And what kind of information are we talking about here? Well, rather, I'm not going to read you the list, but it includes visions, plans, reports, proposals, dialogue, intelligence, indexes, catalogs, all sorts of things. And when people have an interest in a particular subject, it really helps to have some tools that sort of organize that information for you in advance.
We'll start the demo in this classic piece written by our founder, Doug Engelbart, who's our inspiration for this initiative. The hyperscope paradigm offers a variety of ways to view the document. For example, you can trim your view to see just the first line of every paragraph or heading. What is this file I've landed in? Is it even relevant to my pursuit? Adjust the line shown for more or less detail. Or collapse it up to an outline view of the document, adjusting the depth of level shown to suit the moment. In this view, we're seeing blank lines between these paragraphs, and we see more of the document if we hide the blank lines. Again, we can hide or show at will. Based on that outline, these purple numbers are provided as a further visual cue for how it's shaping up, and as a point of reference showing where you are in the document as you scroll. Again, you can hide or show at will. These purple numbers have the added benefit of letting you jump by number. you just click on the number, allowing you to navigate with precision. And always, wherever you find yourself in the document, you can pop back up to the top or origin of the file in one jump. Besides the classic outline view of the document, you can also see a table of contents view showing just the headings. Select from the headings, jump back to the origin, view it as a table of contents, or stop viewing it as a table of contents. In our pre-beta version, we've gone with this dashboard theme, using buttons to make stuff happen. Y and Z, show or hide the blank lines, hide, show. M and N, hide or show the purple numbers. X gives you your outline view. B and A are +1 or -1 more levels, and W for a full view. And T, which actually is mnemonic, gives you the table of contents view, and U reverts back to a full view. And the view specs work in any combination you like. For example, turn on the table of contents, turn off the blank lines, turn off the numbers, turn off the table of contents, and so on.
Okay, so let's take a look at the GitHub for this project, github.com Rangell KFest 2024. So A2P keyset has code for testing a chord keyset using Doug Engelbart's key mappings with 2 simulated mouse buttons. See the keyset JPEG for the schematic. So let's take a look at that. Okay, so this is the wiring, but here is the schematic. So on the game socket, pin 1 is your power, and you have 5 switches going to these pins, which is switch 2, paddle 0, 1, 2, and 3. So this is, say, you have a 2+, and there are other ways of doing this. And your thumb goes here, your pinky goes here, and then I wanted to simulate a 3-button mouse. I'm using 2, 3, and 4, which are switch 0, 1, and 2. Okay, now for Engelbart's design for the switches, you only need 2 buttons. So there are 4 different combinations that he recognizes. So this left and center button are the 2 that are used. So the +5 volts goes to those 2 switches, and you need to have a resistor to ground for them to work on the 2+ and other computers properly. Okay, so this is if you have an internal joystick socket, and that's what the code is configured for. So this 2 and 3 are switches 0 and 1 in the Apple language. Switch 2 is used for the thumb button of the key set. Okay, and then there is a disk image. If you download this disk image, okay, then you run that disk image in your favorite emulator. Shout out to April and Melody. Okay, so it boots up this program. If on the 2+ that I was first testing with, I had to disconnect the ground wire for the shift key mod, but most of the time you don't need that. And now you can test the program here, and then you can list it. So we're going to take a look at this listing. So this is the paddle button 0, C061, which is used to reference all the other buttons. And I am figuring out the character strings for the lowercase and uppercase and the tab. So let's take another look at that chart, the schematic. Okay, so at the bottom of this schematic, we have the key codes. So they are binary from 1 to 31. And normally it's lowercase. So if none of the mouse buttons are pressed, you get lowercase, you get a comma, period, semicolon, question mark, and space. So you push all 5 keys to put spaces between words. And then if you hold down the leftmost mouse button, you'll get the uppercase characters and these characters and the tab. So if you're doing word processing, most of the time you can do spaces and tabs. There's a debate here. Okay, so now if you hold the left button down, okay, that's the right. Okay, so if it's 0, 1, that means your center mouse button is down. If it's your left mouse button is down, yeah, you got to think if you're typing a 1 or you're typing a 2 or you're typing a 3. Okay, now I added some functionality if you're just pressing these buttons without any key set codes to add some characters like the pipe and the tilde. And these are the characters which are the shifted numbers and the numbers, and then the brackets. And then Alt is really an escape key in Engelbart terms, and carriage return. So when you want a carriage return at the end of the line, you're holding the left button. So you're thinking a 2 and you're holding all the buttons down. And then if you hold both of these, now you are doing commands in NLS. So like showing one level less, showing one level deeper, showing all the levels. So this is expanding and collapsing outlines. The recreate display was often needed in NLS to refresh. But these are really view specs. Like, so Plex is a statement and all the sublevels under it. And we saw the M and N for the statement numbers on and off, and Y and Z are blank lines on and off. So you're actually learning these keys for the view specs, and they can be typed with the key set. And that's what gave Engelbart a lot of speed. So yeah, showing one more line or one less line as he's reading the document. So these are features that we do not have in current applications, especially when we're reading things on the web. So Engelbart's vision was to have a single network system and to have all documents integrated where you could jump to links to anywhere between them, similar to Ted Nelson's ideas. Engelbart's is more outline-driven and hierarchical. So looking at this code, yeah, I'm trying to simulate exactly what we saw on that key chart. Okay, so let's see, Control S. Yeah, I print the word base because in NLS, that top line will change based on what you type. I haven't implemented any of that. I may do that on a 2GS version because I would like to change the wiring so that it just uses paddle 2 and 3 to get 8 buttons, because there are 5 on the key set and 3 mouse buttons, and that could be re-engineered, but this is a prototype. Okay, poke 34.2 gives you the 2 lines at the top as you scroll, as you're seeing here. And then let's see. Yeah, there's some special characters, but I'm reading the 4 paddles, and I am doing some garbage collection and printing some magic things. Let's see, 127 and character 8 for the cursor. Okay, then I'm getting the buttons. So buttons 0, 1, and 2, getting the statuses, and checking an array. I'm creating an array from the state of the buttons and the mouse switches. Okay, and then I have phase processing 1. Okay, so there's some crazy logic that I can't figure out what I was doing. And let's see, poke. I am poking the screen. Okay, that's what's doing the little display as I push the buttons. Okay, so then I calculate bytes. See, this is the fun of Applesoft. You could write things and never figure out, yeah, they work, and then you never know how you did anything when you go back and look at your code. Okay, so if byte is 31, so yeah, it's possible to trace through here. I'm blanking, yeah, doing things on the top of the screen, poking. Yeah, so poking the screen is a lot of fun in Applesoft and in machine language. Yeah, here's the Alt key. We fell through to shifted mode. Okay, so I'm really determining what mode it is based on the buttons you pressed. And let's see. Okay, so there's data statements here. And yeah, if you press everything, it exits the program. So here are all the view spec data statements, and that's the prototype for the 2+. On this A2P keyset disk image, there's an Applesoft program called Doug, which you're looking at right now, which is used for testing your keyset. And as you press the buttons, you will see these things go on and off. And when you test your left and right buttons of your 3-button mouse, then you will see those numbers change. Okay, and the main program that simulates Doug's system is called typechord.base, and this is the listing. And you can see data statements with the Engelbart functions. So when you run it, you usually just press return and then you begin typing on your keyboard. And so let's do an H, an E, 5 and 1, yeah, 5, and L is 12, so it's 8 and 4, and O is 15. Okay, and if we want capital, we'd have to use the buttons to use the Engelbart key combinations for that. This is a demonstration of a program called Think Tank by Living Video Text. And it allowed you to create outlines, and this is just a demo disk that came with it that has sample outlines. So let's expand lesson plans. And this unit examines literary content, form, and style through the medium of science fiction. Sounds like a fun class. And let's see what week 1 is. Imagination. You have to read Asimov Nightfall, Bradbury, Mars is Heaven, and Herbert Dune, Part 1. And your assignment, imagine there is life on Blurf, the 4th planet of the Alpha Centauri. Okay, so there is a windowing system here to, let's see, fine-tune the window position. Okay, scroll the text left, or scroll the text down, or up. Okay, and you learn all about, you exit and you're back to where you started. Okay, so what we are looking at is a MUD, but what it is running in is augterm 0.21. And augterm can use a gamepad as a chord key set. So the A button is a 1, B is a 2, C is a 4, D is an 8, and the right arrow is a 16. So if I want to go to the Civil War, I have to type a C, which is 2 plus 1, and a W, which is the right plus A, B, and C, and hit enter. And now I am in the Civil War lobby. If I want to go to the General's headquarters, I need a 7 and an 8 for G and H. Okay, now I'm in the General's headquarters, and if I want to see battlefields, it's a B and an F. So B is a 2, and F is a 6, and I'm in the battlefields. Go back to General's headquarters, 7, 8, and back to the lobby. It's a C, W, and L is a C and a D. That's 8 and 4. And if I want to see other projects, O is number 15. So I type these 4 buttons at once, and you could hold down one and then get the other buttons in and then release them all. That's what the release of all buttons signals the key. And P is a 16. And now I'm at the other projects. If you're interested in learning more about Muse technology and its history, here is some information of how you can create your own Muse and how you can connect to an existing Muse that is still online. And this is a nice one because it also has a play through the web. So here we are going to connect to a server, and you can create a new character or log in as a guest and play with it. So if you want to learn more about MUD technology, I have a playlist. And starting with this video, exploring a MUD from the 1990s, creating your own MUD, running your own personal copy of Micromuse, and multi-user dungeons for education, because these were actually used in classrooms. If you want to keep up with future research that I'll be doing about Douglas Engelbart's systems and how we can revitalize them, this is a tool called Workflowy, which is an outliner on the web. And it's pretty nice the way you can collapse and look at the different things and add links and hashtags. So have fun. Anybody want to know about the background?
All right, I'll ask that question. What's the history of your background?
Okay, this is from 1985 when I attended a gifted children's programming class at Brooklyn College, and they taught low-res graphics. So I created all these little things that you could see behind me, because I knew high-res as well. But I asked the instructor about assembly language, and he said, make sure you know Applesoft very well before you start assembly. So that's the story. And I have a SlackFest video that will talk about it as well.
Okay, thank you. There's quite a bit of chat over in Discord, and there's some questions about how much did Douglas Engelbart know about some of the related work? Was it more of a collaborative environment versus individual researchers working in their own?
I would say back in 1968, it wasn't easy to know what other researchers were doing unless there was correspondence. And so he had his own group that he built at SRI. And yeah, to get to that demo, there was a lot of work in to get that projection system up, to get the telephone links at 1200 baud working, and the video the overlays that you saw. So yeah, it was a really big production, but it had a really big impression because you had the top computer scientists of the time attending that Fall Joint Computer Conference.
Was Jeff Raskin influenced by any of this?
I'm sure he knew about it, and let's see, I think he did some work at Xerox. I don't remember, but he was definitely aware of these concepts. Jeff was more into making the user interface the way he wanted it to eliminate steps. So yeah, I mean, the productivity concepts that, yeah, that was an influence. Because Douglas Engelbart's work was a lot about how humans can better interact and how projects can scale up. So there's a lot to learn and to take forward as we deal with complex problems.
Yeah, thanks for sharing this history. It's amazing what some people in the past have done, the foresight that they had. So thank you for sharing some of that with us.
Hey, thanks everybody. Have a great day.